Now, if you're thinking that was Ted Nugent, you would be thinking along the right lines, but that was actually St. Paradise, a group that broke away with Nugent's old guitarist and bass player, singer and bass player. And but the singer had written the song for both Ted and for himself, so they had it on their one and only album, St. Paradise. Not a bad little group. Here we go. Back into parabolas. Now, we've been looking at parabolas with the vertex at 0, 0. And what we're going to do is we're going to consider the adjustment when we change the vertex to hk. Now, h and k might both represent 0, but not necessarily. So this is a little bit more of a general case. And what we have here are examples where we have one that opens upward, one that opens downward. And again, it's still based on the value of p. And also one that opens to the right and one that opens to the left as well. And that is also based on the value of p here. But you can also see the adjustments to the equations. Notice here, x minus h quantity squared, y minus k quantity squared. So you can see the adjustment. Your vertex is still hk, opens to the right, or excuse me, upward if p is greater than 0, downward if p is less than 0. Notice that the focus here is going to be k plus p. Now, if p is positive, notice that it goes up p units from the vertex. If p is negative, it goes down p units from the vertex. And then the directrix, of course, being the line that's perpendicular to the axis of symmetry. Here are p units below, here are p units above. And the axis of symmetry for these two, both being vertical lines, going through the vertex, so x equals h. And the focal diameter, that's the distance there of the length of the latus rectum, which is that segment that's perpendicular to the axis of symmetry going through the focus. And it has the same focal diameter as it did whether it was 0, 0 or hk. And then very similarly down here, they'll open to the right, to the left. Now, students typically do a little better with these two because they're used to them from the quadratic functions. But they work in the same manner here, whether they open to the right or left. Remember, it opens to the right, p is positive, opens to the left, p is negative. That's what this is saying here. Also notice that the variable y is the variable that's being squared in this expression. And then the focus is either going to be to the right if it opens to the right, to the left if it opens to the left. The directrix, just the reverse, the axis of symmetry here, being a horizontal line, y equals k, because it's got to go through the vertex, and the focal diameter, again, absolute value 4p. So what we'll do is we'll make these adjustments, and we'll go ahead and try to work a problem out where we have a parabola whose vertex is not 0, 0. In this case, can you see what my vertex is going to be here? Can you see my h and k? This is still in standard form. This is still considered standard form for the equation of a parabola. But in this case, I can see that my vertex here, and I think it asks for the vertex here, so I'll go ahead and write v for vertex, is going to be 4, 2. Remember, x minus h, y minus k, x minus h, y minus k. Notice that the y is being squared, so it's this type down here, so it's going to open to the right or to the left. And my vertex here is 4, 2. 4, 2. Now, I know that this one's going to be a little bit bigger, so I made my scales each worth 2 here. So 4, 2 would be right here for my vertex. Okay, because I'm going to graph this here in just a second in part B, but I want to go ahead and put the vertex down. Now, the focus is not actually part of the graph. It's going to be in the interior of the parabola, but we'll go ahead and find the focus. Now, to find the focus, we have to find the value of p. So I am going to set this expression here, I'll put it over here, a little scratch work, 4p is equal to negative 8, so p is equal to negative 2. Now, since p is negative, I know it's going to open to the left. As compared to open to the right, it's going to open to the left, and I'm going to be 2 units to the left of the vertex here. So 2 units to the left, 2 units to the left of the vertex would put me right here at 2, 2. So my focus, I'll just use a capital F for focus here, is 2, 2. Because this thing's going to open this way. Should open this way anyway. And now, the focal diameter, which is the absolute value of 4p, so this is 4p right here, so it's the absolute value of negative 8, which is 8. And that's going to tell me from the focus, which is right here, I just put a little dot here, hopefully you can see that, I am going to go This is 8, so I'm going to go 4 units above and 4 units below for my endpoints of my lattice rectum, which is what it's asking for here now. I want the endpoints of the lattice rectum, so since P is equal, or 4P is equal to 8, I'm going to go half above and half below. So 4 units above puts, oh, excuse me, above the focus, that is, puts me right here, and 4 units below puts me right here. So that, you don't really need that now, but those 3 points should give you a reasonable sketch for your parabola. But as you can see here, this is going to open up pretty wide. You might want to go ahead and plug in like a y value of 0. So if you plug 0 in here for y, which would put me on the y-axis here. If I, excuse me, I said that backwards. If I put in an x value of 0 in here, that's going to give me a positive 32 here. Take the square root, that's 4 square roots of 2, add 2. Oh, that's about 8. So yeah, I'm going to have to get the calculator out to approximate that. But you can find a couple more points by plugging in some values here. I'm going to try my best to get a curve out of this, because that's what it's asking for. By the way, it did ask for to identify them. So the endpoints would be at 2, 6, and at 2, negative 2 for the endpoints here. And then try to make a smooth curve out of this. That could be worse. Also, it says at the bottom here, it says write the equations for the directrix and the axis of symmetry. Well, the directrix, remember the focus was right here. This was a value of 2. So I'm going to go 2 to the right here, which this is at 6. And I'm going to have the vertical line here be my directrix. And that vertical line would be x equals 6. Of course, my axis of symmetry is going to go through the, it's going to be a horizontal line, it's going to be perpendicular. It's going to be a horizontal line here. And it's going to go through the vertex. The vertex here is at 4, 2, so since it is a horizontal line, it's going to be in the form y equals a number, and it has to go through the vertex, so it's going to be y equals 2. So my axis of symmetry is y is equal to 2. Let's try a couple more problems here and see if we can really get a good feel for this.